With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, there are two ideal rings of force constant K1, K2 respectively. When the both springs are relaxed, separation between the friend is L. Now the spring of mass M is attached to the free end of the spring and displaced by a distance 2L toward the left and released, assuming that the surface to be frictionless and K1 by K2 is 4 by 3, it is given. Suppose that M hit the right spring and stick to it. The extension in the left part of the spring when the M mass is in equilibrium position during its motion. So if you see the spring constant, right, these are the spring constant. So I can write down the K2 is, so basically K2, the spring constant in K2 is less, right? So if you see, we want the net force on the block to be 0. So how it can be 0? When the force by the two spring will be equal and opposite as well, right? So how they can be equal and opposite? First of all, spring constant of K2 is less. So the extension in K2 should be more. Like if I say the extension is in the second spring is x2, so it will be more than extension or compression in the first one, right? Since the spring constant times it will be force, right? If you see the force F2, it will be, and it should be force by the other spring, that is this, as we have discussed, right? So if you see the diagram here, right, we want the two forces to be equal, right? And if you see it strikes to it and attached with this spring, right? So let's say the two spring will apply a forces of, if it will be extended, right? If it will be extended and if it will compress this, right, then what will happen in compression part? If you see this, if I say this is x1 and this will be x2, so in compression part this x1 will be more than x2, which we don't want. We want this x2 to be more than x1 because we want the force to be equal, and we know that in case of spring the force is spring constant times the compression or extension. So if k of 1 is less, so x of that, so the compression or extension of that should be more. So here x1 is more than x2, so the compression part it is not possible. An extension is asked. So if you see, this can be a case here, right? Let's say it is extended by some x and this is extended by some distance L minus x, right? Then it is possible that the F1 might be equals to F2 and the net force on the block is 0. So let's see. Here the force by the first spring will be towards left since it is extended, and force by the second spring will be towards right. So I will write down, this is K2 L minus x. So this is F1, this is F2. So this can be a case. So I will equate the two, and K1 x is equals to K2 L minus x. K2 we already have seen, it is 4 by 3 K1, for 3 by 4 K1. So if you cross multiply, you will write down 4 K1 is equals to 3 L minus x. 4x, right? K1 will get cancelled out. 4x is equals to this, and this is 3L minus 3x. So from here you will write down 7x is equals to 3L and x is equals to 3 by 7L. And this is the answer of this question. Now you can check for the option. So B here is the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.